Peter Strelzik kneels on his apartment floor in Pößneck, East Germany, threading a sewing machine needle through two mismatched bedsheets. His wife Doris stands at the window, watching the street below for Stasi patrol cars. The fabric pieces spread across the room are different colors, different widths, bought from different towns over 6 months. They are building a hot air balloon to carry 8 people over the border, using only store-bought cloth and hardware store metal. If the seams fail at altitude, the envelope tears open and drops them into the minefield zone. Strelzik pulls the first stitch tight. 47 pieces of fabric lie across Strelzik's living room, each a different color and width. East German stores stock cloth and bolts no wider than 4 meters, and anything aviation grade requires a state permit that triggers automatic Stasi review. The two families need material for an envelope tall enough to lift 1,600 pounds to 2,000 meters, clearing the watchtower sightlines along the border zone. So they are improvising with bedsheets, curtain lining, and raincoat fabric bought in small quantities from towns scattered across Thuringia. In a garage workshop 15 kilometers away, Günther Wetzel sketches a propane burner on graph paper. He is an electrician, not an aerospace engineer, and no civilian manuals exist for hot air balloon construction in East Germany. His design uses only hardware store pipe fittings welded into a frame that must generate enough heat to lift 8 people without igniting the fabric above it. The calculations are done by hand, estimating combustion temperature and throat diameter from first principles, because there is no one to ask and no library to consult. East German store clerks operate under standing orders. Any customer buying more than 10 meters of fabric in one transaction, or returning within 30 days, must be reported to the local Stasi office. The protocol exists to catch black market tailors and smugglers, but it makes building a 20-meter tall balloon nearly impossible. A single suspicious clerk triggers an investigation that ends in interrogation and 15-year prison sentences. So Doris Strelzik and Petra Wetzel split the shopping, each visiting a different town every week, rotating fabric types to avoid patterns. By July 1979, the families have gathered enough material for an envelope, roughly 1,200 square meters of mismatched cloth, purchased in 8-meter lengths from stores across Thuringia. Doris Strelzik visits towns to the north, Petra Wetzel to the south. They buy curtain lining one week, raincoat nylon the next, bed sheets the week after. Each piece is folded into a shopping bag and driven home separately. The fabric now covers 2 living room floors, waiting to be sewn into a single, airtight envelope whose seams must hold under internal heat pressure. The envelope must be sewn at home because no East German tailor will accept a 1,200 square meter commission without asking questions. Doris Strelzik sews for 6 hours every night after her children are asleep, using a domestic machine designed for curtains and clothing. Each seam must overlap by at least 3 centimeters, or internal pressure will rip it open in flight. She works methodically, panel by panel, matching thread color to fabric color, so the stitching is less visible if neighbors glance through the window. By August, the envelope is half finished. They cannot test inflate the balloon outdoors. Any large fabric structure spotted by neighbors or photographed by aerial surveillance means immediate Stasi interrogation. Strelzik and Wetzel have built their machine using oven tests for fabric heat tolerance, hand calculations for lift, and welding shop experience for burner construction. By late August, they have a finished envelope and a finished burner, but zero empirical data on whether the burner generates enough lift or whether the seams will hold at altitude. The first flight will be the only test. Wetzel welds the burner frame from 20mm steel pipe in his garage, calculating throat diameter by hand to maximize propane flow without creating a blowtorch that ignites the envelope overhead. He estimates the flame must produce roughly 3 million BTU per hour to lift 1,600 pounds, but the exact number is a guess based on industrial welding torches and camping stoves. The steel must be thick enough to withstand continuous combustion heat, but light enough not to eat into the lift margin. He finishes the frame in 3 nights, then wraps the joints in heat tape to prevent propane leaks. Propane tanks are available at camping-supply stores, but each purchase is logged in merchant records. Wetzel and Strelzik buy 4 tanks over 3 months, spacing the purchases across different stores and claiming they belong to a camping club that does not exist. Each tank holds enough propane for roughly 20 minutes of continuous burn, so they need at least 2 tanks for a flight long enough to cross the 15-kilometer distance from their chosen launch site to the border. A third purchase at the same store would trigger merchant scrutiny, so they accept 4 tanks as the maximum they can acquire safely. Strelzik tests fabric samples in his kitchen oven, slowly raising the temperature to find the maximum heat tolerance without melting or igniting the material. Synthetic blends melt at 180 degrees Celsius. Cotton chars at 220, and nylon seams fail first under sustained heat. He records the results in a notebook, matching fabric type to safe operating temperature. The burner flame will reach over 1,000 degrees at the throat, but by the time hot air rises into the envelope, it should cool to roughly 100 degrees above ambient. Should. He has no way to measure it in flight. Each seam must overlap by 3 centimeters, Doris Strelzik knows, because anything less allows internal pressure to pull the stitching apart once hot air fills the envelope. She sews panel by panel, checking the overlap with a ruler after every meter of stitching. Mistakes cannot be patched. There is no spare fabric. By late August, she has sewn over 400 meters of seam, and her hands ache from the repetitive motion. The envelope is nearly finished, but she has no way to test whether the stitches will hold when the balloon is inflated and heated to flight temperature. Every car slowing on the street below feels like a Stasi patrol. Every neighbor's glance through a window feels like a report being filed. Wetzel wraps the burner in blankets and hides it in a storage closet. Strelzik folds the envelope and stores it under bedding in a wardrobe. They stop discussing the plan on the telephone because East German lines are monitored. They meet in person, in parks or on rural roads, speaking quietly and watching for parked cars that might contain listening equipment. The project is nearly complete, but the risk of detection has never been higher. By late August, both components are finished: a 20-meter-tall envelope sewn from 1,200 square meters of fabric, and a propane burner built from hardware store pipe. Together, they weigh roughly 200 pounds, leaving 1,600 pounds of lift capacity for 8 people and a wicker basket. The families have no engineering degree, no aviation training, and no test data. They have built a flying machine using only a sewing machine, a welding torch, and high school physics. Whether it will work is a question they cannot answer until they light the burner and release the tether. September 4, 1979, midnight. Both families load the folded envelope and burner into a delivery van borrowed from Wetzel's workplace. The children are told they are going on a camping trip. Strelzik drives south toward the border while Wetzel navigates using a hand-drawn map marking forest clearings far from roads and watchtowers. They choose a site 15 kilometers from the border fence, close enough for a short flight but far enough to avoid immediate ground patrols. At 1:30 a.m., they pull off a dirt logging road and begin unloading the equipment in darkness. Strelzik spreads the envelope on the forest floor and connects it to the burner frame. Wetzel opens the propane valve and ignites the flame. Hot air rushes into the envelope and the fabric begins to rise. It takes 12 minutes for the balloon to fully inflate, the patchwork panels stretching taut as internal pressure builds. The children climb into the wicker basket, followed by the adults. At 1:47 a.m., the envelope lifts the basket off the ground. Wetzel pulses the burner to add heat, and the balloon climbs smoothly into the night sky. For 4 minutes, everything works. At 1,200 meters altitude, Strelzik realizes the wind is pushing them southeast, parallel to the border instead of across it. He has no instruments and no steering. Hot air balloons move with the wind. Altitude is the only control. He vents hot air to descend, hoping the surface wind is blowing in a different direction. But the balloon drops faster than he expects. The envelope cools rapidly without burner heat, and descent accelerates. At 1:56 a.m., 9 minutes after liftoff, the basket slams into tree canopy and crashes through branches into a forested area still inside East Germany. The basket hits the ground and rolls twice. The envelope tears on branches overhead. All 8 people survive with cuts and bruises, but the balloon is destroyed. They abandon the wreckage, carrying the burner and propane tanks back to the van and hiking through darkness to the logging road. By dawn, they are back in Postneck, exhausted and terrified, knowing the Stasi will find the crash site within hours. The only thing protecting them is that the wreckage looks like sabotage or a Western smuggling attempt, not a homemade escape. Within 48 hours, Stasi patrols discover the crash site and issue a district-wide alert. The torn envelope and abandoned burner frame are labeled as evidence of Western sabotage or an illegal border crossing attempt. The investigation focuses on fabric and propane, but the Stasi has no suspect list because the purchases were distributed across dozens of stores and months of time. Strelzik and Wetzel monitor local radio and see no mention of their names. The investigation is active, but it has not yet reached them. They have a narrow window to rebuild and try again. Strelzik and Wetzel have 3 weeks to sew a new envelope before winter weather closes the launch window. They also have 3 weeks before the Stasi investigation connects fabric purchases in Thuringia to families near Poznek. Doris Strelzik begins sewing again, this time working 10 hours a day. They cannot buy more fabric without raising suspicion, so they use reserves they hid in storage and sew the new envelope slightly smaller, reducing its volume to 2,400 square meters. The seams are tighter, the stitching faster, and the risk of detection higher with every passing day. A hot air balloon flies because propane combustion heats air inside the envelope to roughly 100 degrees Celsius above the surrounding temperature. Hot air is less dense than cold air, so it rises, and the upward force equals the weight of the air displaced by the envelope volume. Wetzel's burner must vaporize liquid propane through a 15mm throat and mix it with air at a ratio of 1 part propane to 15 parts air. That combustion produces approximately 3 million BTU per hour, enough to lift 1,600 pounds if the envelope volume is at least 2,800 cubic meters and the seams hold. Each seam experiences tensile stress from internal pressure as hot air pushes outward against the fabric. The stitching must distribute that load evenly, which is why Doris Strelzik overlaps every seam by 3 centimeters and uses double stitch patterns. A gap wider than 2 millimeters allows the fabric to pull apart under pressure, starting a progressive tear that unzips the envelope in seconds. With 1,200 square meters of seams holding the balloon together, any single failure point can destroy the entire structure. The stitches are the only thing keeping 8 people alive at altitude. Hot air balloons have no lateral control. They move with the wind, and the only thing a pilot can adjust is altitude. Adding burner heat makes the balloon rise. Venting hot air through a port at the top makes it descend. Wind direction at ground level can differ from wind direction at 2,000 meters by as much as 90 degrees. So Strelzik has to guess which altitude will carry them northwest toward the border. If he climbs into the wrong wind layer, they drift parallel to the border or back into East Germany. There is no way to correct course once airborne. East German border watchtowers are equipped with thermal imaging scopes effective to 3 kilometers. A hot air balloon envelope glows white on those displays because the fabric radiates heat from the air inside. The only way to avoid detection is to fly above low cloud cover or to launch during a night when the towers are scanning the wrong sector. Strelzik plans to climb to 2,000 meters and enter clouds as quickly as possible, gambling that thermal scopes lose tracking once the balloon is obscured. But clouds also eliminate visual navigation, leaving him blind to landmarks and border fences below. September 15, 1979, offers the last favorable weather before winter. Surface wind from the south at 8 kilometers per hour, upper-level wind from the southeast at 12 kilometers per hour. Both winds will push the balloon northwest toward the border if Strelzik launches from the correct clearing. Cloud cover is predicted at 2,000 meters after midnight, which provides thermal concealment but eliminates ground reference. The forecast is based on a hand-drawn wind map Strelzik compiled using radio weather reports and observations from 3 previous nights. If the wind shifts again, they land back in East Germany. If the burner fails mid-flight, the envelope cools at approximately 2 degrees Celsius per minute. As the air inside cools, buoyancy decreases and the balloon begins to descend. Without burner heat, the descent rate accelerates to 5 meters per second, which is unsurvivable in a wicker basket landing on forested terrain. Strelzyk will carry 2 propane tanks, enough for roughly 40 minutes of flight if he pulses the burner to maintain altitude instead of running it continuously. Running out of fuel before reaching the border means a controlled crash back into East Germany, with border patrols arriving within minutes. 2 a.m., September 15. Both families drive to a new clearing 2 kilometers farther south, selected by Strelzyk using compass bearings to the nearest West German town and his hand-drawn wind map. The clearing is smaller and closer to a patrol road, but it aligns better with the predicted wind direction. They unload the envelope and burner in darkness, working silently. The children are awake now and understand this is not a camping trip. Wetzel connects the propane tanks while Strelzyk spreads the fabric on the ground. At 2:12 a.m., Wetzel opens the valve and lights the burner. The new envelope inflates in 10 minutes, faster than the first balloon. The tighter seams and reduced fabric weight allow the hot air to fill the volume more efficiently. Strelzyk watches the fabric rise and checks the seams for gaps or tears. Nothing fails. By 2:22 a.m., the envelope is fully inflated and pulling upward on the basket. The 8 people climb in and Wetzel pulses the burner to add heat. At 2:17 a.m., the balloon lifts smoothly off the ground and climbs into the darkness. The first test is passed. The burner generates enough lift. Strelzyk pulses the burner every 45 seconds to maintain a steady climb. The balloon rises through 1,000 meters, then 1,500, then 1,800. He holds that altitude by balancing burner heat against cooling air. There are no instruments, so he estimates altitude by counting seconds since liftoff and feeling the air temperature drop. 8 minutes into the flight, they enter cloud cover at 2,000 meters. Thermal scopes below lose tracking, but Strelzyk loses all visual reference for landmarks, roads, or the border. He is flying blind now, trusting the wind prediction and a stopwatch. Strelzyk cannot see the ground, so he navigates by stopwatch. He estimates the balloon is moving northwest at 12 kilometers per hour, which means they should cross the border in roughly 22 minutes of total flight time. He counts each minute aloud, pulsing the burner to maintain altitude. Wetzel monitors the propane tanks, listening for the hiss of vaporizing fuel. The children sit silently in the basket, holding on to the wicker edges. At 19 minutes, the first tank empties. Wetzel switches to the reserve tank and tells Strelzyk they have 20 minutes of fuel remaining. At 22 minutes, Strelzyk vents hot air to descend below the cloud cover and confirm their position. The balloon drops quickly, breaking through clouds at 600 meters altitude. He looks down and sees searchlights 4 kilometers behind them, scanning the wrong sector. The border towers have not spotted the balloon. Ahead, he sees dark, forested hills with no visible roads or lights, which means they are either in the border zone or already across. He cannot tell which. The only option is to land and hope. Strelzyk vents fully. The balloon descends at 4 meters per second and crashes through tree canopy at 2:39 a.m. Branches tear at the envelope and the basket slams into the ground, rolling twice before coming to rest on its side. Wetzel cuts the burner and the propane valve. The envelope collapses over the trees, torn and deflated. All 8 people are alive. Wetzel has a fractured wrist. 2 children have cuts from branches, but everyone can walk. They climb out of the basket and stand in the darkness, waiting for dawn to reveal where they are. At dawn, West German border police arrive, drawn by the torn fabric visible in the trees. They measure the distance from the crash site to the border fence using surveying equipment and confirm the basket came to rest 10 meters inside West Germany. The families cross successfully. All 8 people are processed as refugees and transported to a reception center in Bavaria. The Strelzyk and Wetzel families are free, but the balloon is destroyed and the burner bent beyond repair. The machine that carried them over the wall will never fly again. Wetzel receives treatment for a fractured wrist at a West German hospital. 2 children are treated for lacerations from tree branches during the crash. All other injuries are minor, bruises and cuts that heal within days. The families spend 2 weeks in a refugee reception center before being resettled in Bavaria. They are interviewed by West German intelligence, who document the balloon construction and flight path in detail. The Strelzik and Wetzel families ask not to be identified publicly at first, fearing reprisals against relatives still living in East Germany. The Stasi closes its investigation in October 1979, after interrogating 78 merchants across Thuringia and finding no clear suspect. The distributed fabric purchases worked. No single store clerk could connect the transactions to a single buyer or family. The crash site from the first attempt remained classified as Western sabotage, and the Stasi never connected it to the successful September flight. By the time the Strelzik and Wetzel families were publicly identified in West German media, the investigation had already been archived, and the families' East German relatives faced no reprisals. West German engineers examine the wreckage and calculate the balloon generated a lift-to-weight ratio of 1.125 to 1. Barely sufficient, but proof that hot air balloons can be built without aviation-grade materials or formal training. The seam construction is noted as the critical success factor, because a single weak point would have torn the envelope apart. The improvised propane burner is analyzed and found to have operated at roughly 85% of the theoretical maximum efficiency, which is considered remarkable given the lack of engineering specifications or test data. NATO updates border crossing protocols in late 1979 to include low and slow aerial threats, recognizing that improvised aircraft can evade radar and thermal detection under certain weather conditions. The Strelzik-Wetzel escape is cited in classified briefings as proof that determined individuals can overcome sophisticated surveillance systems using only hardware store components and basic physics. East Germany responds by adding fabric and propane to the list of controlled goods requiring purchase permits, though enforcement remains inconsistent due to the sheer volume of legitimate civilian demand. The escape becomes the basis for the 1982 Disney film Night Crossing, starring John Hurt and Beau Bridges. The film compresses the timeline and omits the first failed attempt, focusing instead on the successful September flight. It dramatizes the fabric-buying surveillance and the burner construction, though some technical details are simplified for narrative pacing. The Strelzik and Wetzel families consult on the production, but express frustration in later interviews that the film emphasizes desperation over engineering problem-solving. The movie introduces the escape to a global audience and remains the most widely known account. Peter Strelzik and Günter Wetzel give interviews through the 1980s, and both men consistently emphasize the engineering process rather than the political context. Strelzik tells one West German reporter that the hardest problem was not the Stasi, but calculating burner heat without melting the envelope. Wetzel describes the seam stitching as the most stressful part of the project, not the surveillance. Their framing rejects the Cold War narrative of desperate refugees, and instead portrays them as competent mechanics, solving a series of cascading technical problems under resource constraints. The balloon remains the only successful improvised hot air crossing of the East German border in history. 14 other attempts between 1979 and 1989 were intercepted by patrols or crashed before reaching the border zone, and none used the bedsheet and propane method. The Strelzik-Wetzel design required a specific combination of distributed procurement, amateur meteorology, and high-precision sewing that later imitators could not replicate under the same surveillance pressure. The success was not repeatable, which makes it historically unique rather than the start of a trend. The escape proved that totalitarian surveillance systems have exploitable gaps when individuals distribute risk across space, time, and anonymity. It also proved that complex machines can be built without formal engineering training if the builders understand first principles and accept narrow margins of success. The balloon did not need to be safe, only sufficient. The seams did not need to be perfect, only strong enough for 28 minutes of flight. That calculus, accepting minimum viable performance under maximum constraint, is what allowed two mechanics to out-engineer a police state. Peter Strelzik and Günther Wetzel both settled in Bavaria and continued working as mechanics. Strelzik passed away in 2017, Wetzel in 2021. Their children, who were between ages 2 and 15 during the flight, have given interviews describing their memories of the night launch and the crash landing. The families remain in contact and gather periodically to mark the anniversary of the escape. In 2019, on the 40th anniversary, the German government recognized the flight as a significant act of Cold War-era self-determination and engineering ingenuity. Fragments of the balloon envelope and the bent burner frame are preserved in the Haus der Geschichte Museum in Bonn, Germany, as part of a permanent Cold War exhibition. Visitors can see the mismatched fabric panels and read descriptions of the sewing process, the propane calculations, and the 28-minute flight. The exhibit emphasizes the improvised nature of the design and the narrow margin between success and failure. It is one of the most visited Cold War artifacts in the museum, alongside pieces of the Berlin Wall and Stasi surveillance equipment. The escape is now taught in some German engineering and design programs as a case study in constraint-driven problem-solving. Students analyze the distributed procurement strategy, the hand-calculated lift equations, and the seam-stitching precision required to hold the envelope together. The lesson is not about politics or bravery, but about how first principles and iterative testing can substitute for formal training and specialized materials. The balloon proves that engineering is less about resources and more about understanding the physics well enough to accept minimum margins. The bedsheet balloon teaches that surveillance systems designed to catch organized networks often miss individuals who distribute risk and randomize patterns. It teaches that complex machines do not require advanced materials if the physics are understood and margins are accepted. And it teaches that improvised engineering under constraint is not about genius, but about discipline, precision, and the willingness to test a machine only once, when failure means capture or death. Those lessons outlasted the Cold War and remain relevant wherever people face resource limits and hostile oversight. On the night of September 15, 1979, two families rose from a dark forest clearing in a balloon made of bedsheets and propane, flew blind through clouds for 28 minutes, and crashed 10 meters inside West Germany. They carried no weapons, no radios, and no backup plan. What they carried was a sewing machine's worth of seam work, a welder's understanding of combustion, and the knowledge that if the wind shifted or the fabric tore, they would fall into a minefield. The balloon worked because it had to. The families survived because they built it well enough. That is the story.